This is part 2 of Factor Theorem, so if you haven't seen part 1 already, then go and watch that now, because over there it shows you how to solve questions like these. If you have seen it, then let's get on with this one quickly, because there's a much more difficult one that we need to put our focus on. Now, this bracket here, we know we have to set it equal to 0, and in this case that means putting x as 2.5. So like last time, let's substitute that in. So just in the interest of time, I'm going to expand it all in one go, but you don't have to do that. So now that we've got this, when you put it in your calculator, all of this should come out to be 0. And when it does, you know that you've answered the first part of the question correctly. So this question here is probably the main subject of the video, so if you can get a grasp on this, then you're going to be doing pretty well. But the first step is to remember that we just proved that 2x minus 5 is a factor of this expression here. So we're going to write that down. And then what you want to do is this expression here, you want to write it under what looks like almost a big bus stop. Okay, so the first step is going to be to take this 2x cubed here and almost compare it to the 2x. Think, what do I need to multiply 2x by in order to get 2x cubed? And you should say x squared, which I'm going to write over here just because it looks nicer since it's above this x squared over here. So now at this point, we're actually almost going to do the reverse, and we're going to take this x squared here, we're going to multiply both of the terms over here by that x squared. So we're going to say x squared times 2x is 2x cubed. X squared times minus 5 is minus 5x squared. At this point, what you're going to want to do is almost treat it like a subtraction. So these two obviously just cancel out, 0. Now this is a negative here, and don't be tempted into thinking that it's minus 12x squared, because you're taking this away. So it's a double negative, meaning you're going to get left with minus 2x squared. So now that we've got to this point, what we're going to say is we're going to do what we did earlier, and we're going to take this minus 2x squared and kind of compare it to the 2x, but this time it's going to be minus x, right? Because minus 2x squared divided by 2x is just going to give you minus x. Now what we're going to do is drop this down, and we'll see why in a sec. And like we did earlier, we got this minus x here, so we're going to multiply it by the two terms over here like we did earlier. So minus x times 2x is going to be minus 2x squared. And again, we're seeing that similarity from earlier where the first term always cancels out with itself. Minus x times minus 5 is going to give you positive 5x. Subtract again. So because we've got this minus 12x here, when we compare it to the 2x over here, we see that we get minus 6 here, because 2x times minus 6 is the minus 12x over here. Now at this point you're done, to be honest, but if you did want to check it, which is fair enough, drop the plus 30 down here. And when you take this minus 6 and multiply it by the two terms over here, you will just get minus 12x plus 30, plus 30 again. When that cancels out to be 0, you know that you've got it correct over here. So what we've proved there is that this expression can be written as 2x minus 5 multiplied by x squared minus x minus 6. Now, that is definitely a step in the right direction, but we have to factorize this quadratic into double brackets, which I'm not gonna do here just in the interest of time, but that will end up coming out to x minus 3 x plus 2. Now that we've got to this point, it's time for what I'd probably say is one of the easiest steps, and the last step. We just have to set all of these brackets equal to 0. So to do this, we have to do positive 2.5. over here it's going to be positive 3. And finally over here it's going to be minus 2. And once you have this, that is your answer to this lovely question over here. So that was a lot, but I hope you guys understood, and I'll see you in the next part.